every advanced technology that will take us to Mars. A variety of cutting-edge technologies are being developed to support humanity's ambitious mission to Mars. In addition to deepening our knowledge of the cosmos, this exploration seeks to establish human presence on a different planet. Here are 7 key technologies that will play a pivotal role in making our journey to Mars possible. Number 7. Advanced propulsion systems. In particular, for missions to Mars, advanced propulsion technologies are essential to realizing the goal of interplanetary travel. One of the most promising technologies being developed in this field is nuclear thermal propulsion (NTP). It works by heating a propellant, usually liquid hydrogen, in a nuclear reactor. This produces a high-efficiency thrust that can launch spacecraft much faster than with traditional chemical rockets. NTP has a specific impulse ISP of up to 900 seconds, while typical rocket fuels have an ISP of about 450 seconds or less. Shorter travel periods result from this efficiency, and NTP journey to Mars might take 3 or 4 months instead of the 6 months or more of a traditional expedition. This reduction is essential for bettering mission logistics and reducing astronauts' exposure to hazardous cosmic radiation because it frees up more time for research and exploration on the Martian surface. In addition, solar electric propulsion (SEP) uses photovoltaic cells to produce energy for ion thrusters, which shoot ions out of their bodies at rapid speeds. This technique offers sustained thrust over long durations, which makes it especially appropriate for deep space missions where fuel economy is critical. Future missions can be planned with more flexibility and ambition by combining these cutting-edge propulsion systems, opening the door to the prospect of crewed trips to distant planets or even asteroid mining operations. Number 6. 3D printing. This reduction frees up more time for Martian surface research and exploration, which is critical for improving mission logistics and lowering astronauts' exposure to dangerous cosmic radiation. Moreover, solar electric propulsion (SEP) generates energy for ion thrusters, which eject ions from their bodies quickly using photovoltaic cells. This method is particularly suitable for deep space missions where fuel efficiency is crucial because it provides sustained push over extended periods of time. Combining these state-of-the-art propulsion systems allows for more flexibility and ambition in the planning of future missions, potentially leading to crewed expeditions to far-off planets or even asteroid mining operations. With the aid of sophisticated 3D printing technologies, astronauts may build habitats layer by layer, enabling complex designs that maximize usable space and save waste. In addition, this technology makes it possible to produce tools and replacement parts on demand, which frees astronauts from having to wait for Earth-based resupply trips to modify their equipment in response to changing needs. Astronauts are able to design and implement innovative solutions that are specifically suited to their tasks and difficulties, which improve operational efficiency and safety while also improving mission sustainability. Number 5. Inflatable heat shields. An important advancement in landing technology, inflatable heat shields solve one of the biggest obstacles to safely transporting cargo to the Martian surface. There are size and weight restrictions on traditional rigid heat shields, which limits the amount of cargo that can be safely delivered during atmospheric entry. A solution is provided by inflatable heat shields, which use lightweight materials that inflate during descent to increase the surface area available for heat dissipation when the spacecraft approaches the Martian atmosphere. High velocities about 27,000 miles per hour or 12 kilometers per second. These shields' unique construction enables them to endure extremely high temperatures, up to 1,600 degrees Celsius or 2,912 degrees Fahrenheit at entry. Their capacity to safeguard heavier payloads, such crewed spacecraft fitted with life support systems and scientific instruments, while guaranteeing secure landings on Mars, has been proven by successful experiments. Numerous prototypes and simulations have been used to validate the technology, demonstrating its efficacy in real-world scenarios. Inflatable heat shields are essential for establishing a permanent human presence on Mars and permitting future exploratory missions that need major infrastructure, as they allow larger and more complicated systems to land safely on the planet. Number 4. Reliable energy sources. Life on Mars requires a steady and dependable energy source because the planet's climate can be harsh and unpredictable. Because solar energy is abundant, it is the most practicable choice. Nevertheless, efficient techniques of utilizing it are necessary to guarantee power availability continuously during the Martian day-night cycle and during weeks-long or even months-long dust storms. In order to optimize energy capture even in low light or during periods of diminished sunshine caused by dust storms, more efficient advanced solar panels are being created. Modern photovoltaic materials are used in these panels, which have higher efficiency rates than conventional solar cells when it comes to converting sunlight into electricity. Additionally, scientists are looking into the possibility of nuclear power as a reliable energy source for lengthy trips. Instead than depending entirely on solar energy, small modular reactors (SMRs) might offer a steady power source for scientific research and housing, guaranteeing that astronauts would always have access to necessities like water purification and oxygen production equipment. Nuclear and solar energy combined could provide a stable energy system that could support future crewed flights as well as attempts to colonize Mars. This dual strategy would maximize resource usage and provide redundancy in the power supply. Number 3. Laser communication. The great distance between Mars and Earth creates communication issues that call for creative solutions to get over the conventional drawbacks of radio communication techniques. Due to signal delays brought on by distance, conventional radio communications have considerable difficulties. Depending on planetary alignment, messages might take anywhere from 3 to 20 minutes to send. This causes communication lags that make mission operations more difficult. By using light beams rather than radio waves, laser communication technologies provide a promising substitute that enables data to be transmitted at considerably higher rates and with a larger bandwidth capacity than is possible with conventional methods. These systems have the potential to reach several gigabits per second, which is 100 times faster than current radio communication methods. This means that real-time video feeds, high-resolution photos, and huge data transfers from Mars missions back to Earth can be accomplished with minimal latency. This capacity is essential for keeping in touch with astronauts, as well as for promoting scientific cooperation between Earth-based and Martian research teams. Improved communication guarantees that astronauts doing experiments on the Martian surface get vital information about safety procedures or environmental conditions in real time, as well as mission objectives. Number 2. High-tech spacesuits. The creation of cutting-edge spacesuits is crucial for astronauts' safety and performance on missions to Mars, where hazardous conditions include high temperatures, radiation exposure, and abrasive dust from the Martian atmosphere. Given Mars' scan atmosphere about 0.6% of Earth's, these high-tech suits will feature advanced life support systems that are intended to provide breathable oxygen while maintaining ideal pressure levels within the suit's internal environment. In equatorial locations, temperature extremes ranging from minus 125 degrees Celsius (195 degrees Fahrenheit) at night to plus 20 degrees Celsius plus 68 degrees Fahrenheit during the day will be regulated using advanced thermal insulation materials. Thanks to innovations like smart fabrics embedded with sensors, astronauts will be able to respond quickly in the event of any potential health issues or hazards while exploring the planet's surface. These sensors will allow suits to monitor vital signs such as heart rate, body temperature, and hydration levels in real time. These suits will also be made to be mobile. They will have articulated joints that provide a wider range of motion, enabling astronauts to carry out difficult jobs like carrying out scientific research or fixing equipment while staying comfortable and safe in the hostile Martian environment. Number 1. Autonomous rovers and drones. By completing preliminary reconnaissance missions prior to crewed landings, autonomous rovers and drones are expected to play an increasingly important role in efficiently investigating the surface of Mars while lowering the hazards associated with human exploration operations. In order to conduct scientific experiments like analyzing soil samples or looking for evidence of past microbial life, these robotic vehicles are outfitted with sophisticated navigation systems, including artificial intelligence algorithms. This allows them to function independently or semi-autonomously without direct control from Earth, which is necessary given the communication delays involved in interplanetary travel, which can last up to 20 minutes round trip depending on planetary alignment conditions at any given time during mission operations. Drones can access difficult-to-reach areas that rovers cannot navigate due to terrain challenges like steep cliffs or deep craters, where traditional wheeled vehicles may struggle or become completely immobilized due to their limited maneuverability capabilities compared against those offered by rotorcraft designs featuring vertical takeoff and landing capabilities. The success of NASA's Ingenuity helicopter has demonstrated the potential of aerial exploration on Mars. Future missions will be able to collect a lot more data about Martian environments faster by combining these technologies: drones that can conduct aerial reconnaissance and rovers outfitted with sophisticated sensors that can collect geological data than if they relied only on human-operated vehicles. Every invention is essential in tackling the distinct problems that come with extraterrestrial life and clearing the path for upcoming space missions. If you liked our video, please hit the like button and subscribe to our YouTube channel.